Hi, welcome to How to Succeed in Physics, and today I'll be talking about distance, velocity, and acceleration. For our problem today, I'll be using the OpenStax College Physics textbook, problem 28 in chapter 2, and that's on page 82. The problem says a powerful motorcycle can accelerate from rest to 26.8 meters per second or 100 kilometers per hour in only 3.90 seconds. And part A says, what is the average acceleration, which I'll be answering now, and part B is how far does it travel in that time? So first we should figure out what we know and don't know. So what we don't know is the acceleration or the distance traveled, but we do know some stuff, and we're going to write that on the right-hand side of the page. So a motorcycle can accelerate from rest. So that means our initial velocity is zero, absolute zero meters per second. And it's going to accelerate to 26.8 meters per second or 100 kilometers per hour, and that's going to be my final velocity, v equals 26.8 meters per second. I'm going to pick meters per second because those are SI units, and whenever I can, I want to use SI units. I also know the time, which is 3.90 seconds, and so I'm going to keep those on the right-hand side. So on the left, I'm going to write what I'm looking for. So what I'm looking for is the average acceleration, so I can write A equals question mark. And then I'm going to use these four different variables I have and figure out an equation that relates all four of them together. So if I go to page 77 in my OpenStax textbook, I'm going to find these five different equations, and I'm going to look for one that has only these four variables. Okay, so to me it looks like the third one. I mean, you can take a look at all of them, but the third one has only final velocity, initial velocity, acceleration, and time. So that's the one I want to use. Alternatively, you can find a section in the Veritas study guide covering one-dimensional kinematics, and we have all those equations there as well. Okay, so I've got my three knowns, my one unknown, and the equation that's going to relate the four together. So first I want to solve that equation for the unknown variable, and then I'm going to enter all these numbers at the end. So our original equation was v equals v0 plus at. So I want to solve for a. That means I want to move the a part to the left-hand side and move the other part to the right-hand side. So all I do is flip. Then I want to isolate that unknown term by subtracting v0 from both sides so that I'm just left with at equals v minus v0. Finally, I want to divide everything by t because I just want the a standing alone. And so my final result will be that a is equal to v minus v0 divided by t. So when I take those knowns and I plug them into my equation, I'm going to get a number that's 26.8 minus 0 divided by 3.90 meters per second, or simply 6.87179 with a lot of numbers that my calculator gives me meters per second. So the thing is, before I box that answer and hand it in, I want to make sure I have the right units and the right sig figs. Since I was given 26.8 meters per second and 3.90 seconds, both of those numbers have 3 sig figs, and that means my answer has to have 3 sig figs as well. So I'm going to round 6.87179 to 6.87. And then for units, meters per second is the same as meters per second squared, which I recognize as units of acceleration. So I'm going to trust my answer and go with that a is equal to 6.87 meters per second squared.